These spinning lines allow us to experiment with different materials and different spinning parameters. Furthermore, they allow us to produce sufficient quantities of filaments for prototyping in composite and textile applications.
During the extrusion, the nanocellulose simultaneously gets a supportive coating around it. And under this coating, it is easily possible to stretch and wind continuously even nanocellulose.
Throughout the ages, Sweden's gold has come from its forests. Its wood has built their houses, given them timber and paper for export. Now scientists want to do even more. They are finding future riches inside the very makeup of wood. The new treasures to be created are high-tech materials, as valuable as precious metals and stronger than Kevlar, but made from trees.
From the wood, we can use the smallest components to build high-performance material concepts like high-performance cars. We can use it for medical purposes inside our bodies, and we could possibly even make bulletproof vests.
The Wallenberg Wood Science Center is a collaborative research effort between the Royal Institute of Technology and Chalmers. Today, we're at the facility on the grounds of the Royal Institute in Stockholm. Two things will come out of this research: new materials and a whole new type of knowledge. What we make with wood will look very different in the future.
We don't really have the perfect answer where we're going to use our materials. We see a strong possibility for interiors in cars and trains, and we also see that these materials can substitute plastics and metals in many cases. And if we knew the answer, they would already be an industrial application.
Wood is going high-tech. This is all about nanotechnology, about forming new materials on the atomic level. The potential here is of historic proportions, but it is also very difficult. When applying nanotechnology to wood, the first problem is how to extract the nanomaterial from the trees. An average forest pine tree holds a lot of water. If we take this away, we are left with about half of the bulk material. But of the rest of this, the other half, everything can be used to produce nanomaterials. These are what give a tree its strength and holds it together. The cellulose fibers that we normally call pulp. But the journey from paper pulp to nanomaterial requires extremely hard processing in machines which these scientists are only now developing.
This machine is the first step of processing and getting nanocellulose. So in this one, you put wood chips from the forest, and by processing it inside, you get paper-making pulp that you traditionally make paper from. So this is the paper-making pulp that came out of the previous process we looked at, where we put the wood chips inside. And this pulp is then put into the equipment behind us, where we are supposed to produce nanocellulose at large scales. So what will come out of that machine eventually is this type of nanocellulose.
Here, every single wood fiber is divided 40 million times. And in this stuff lies the real possibilities. The fact is that this has already resulted in a completely new material created here at the Wallenberg Wood Science Center. Researchers have taken nanocellulose and added a foaming agent to it, a surfactant much like ordinary dishwashing liquid, so that when the nanocellulose is beaten, it becomes a foam. The foam is then dried, and from that, these scientists have created a new material called cellofoam.
We think that this is the foam material that we could use to, for example, pack something fragile if you want to ship your goods, but also use the cellulose ability to absorb water, so for instance in a diaper or something like that, but also use the strength of the cellulose fiber, and you can use this material as a cushioning effect. And we made this helmet to just show that we can make materials of this today, where we use cellofoam inside this helmet to make a cushioning effect. And this is a prototype of a bicycle helmet. It's not something we sell today, but just to show that it's possible.
So how does this become bulletproof vests? Well, to make those, the nanocellulose has to be processed much more than the material in the bicycle helmet.
In order to utilize these fantastic properties of the nanocellulose, we have to develop materials where we put the nanocellulose together very structured. And in this case, we have a setup where we have the nanocellulose that we saw before. We have water and salt. And by using these together in this equipment, we are spinning out a filament or a thread that is super strong and has excellent performance.
This nanocellulose is made up almost entirely of water. The solution is gelatinous, but by allowing the gel to flow in the right manner, with water containing the right amount of salt, scientists can get the pieces of this nanocellulose and nothing else to stick to each other and become an entirely new material. The result is a thread which is super thin but extremely strong. In the future, this will be used to make larger materials which are greener than plastic and stronger than Kevlar, to make bulletproof vests, cars, or any number of things that we haven't even thought of yet.
The starting point we have here with all of these material concepts that are emerging from Wallenberg Wood Science Center makes the future extremely bright for materials from the Swedish forest. We will be able to make both materials we have today and exceptional new materials that have new functionalities and really helps us in our daily life.